Hello children and welcome to my channel Chemistry by Ms. Nidhi Banga. Today we will be talking about all the activities of chapter 1 Chemical Reactions and Equations. We have in total 11 activities in this chapter. We'll be doing 10. One activity I feel is better taken in the next chapter because there it's in more detail. So we'll discuss it there. Rest 10 activities we will be taking in today. Now these activities I have taken the picture and then there are questions based on them. So this is not a question taken from any book. It's the activity and questions taken from many questions from various books. So it has a sum total of all questions, all possible questions that can be asked from any activity. Okay, so let's get started. So the first activity is magnesium burning in the air. So you have magnesium ribbon. It's being introduced into the flame, right? And there's a product that is collected in the watch glass here. The product is white in color. The name of the product may or may not be given to you. Okay, so let's discuss the questions based on them. First is, why should magnesium ribbon be cleaned before burning in the air? Now, we know that magnesium is a very reactive metal. We know that much. It combines with air. It combines with oxygen in the air and forms a layer of magnesium oxide which renders it inactive, which interferes with the burning. So to remove this layer, we clean it with sandpaper. This also happens to be an in-text question of your book. Okay. Next is type of reaction. Now let's see what's happening in this reaction. In this reaction, actually the same reaction is happening, which takes place at a very slow rate at the room temperature. But when you give it a high temperature like we did by introducing it into the flame, the reaction takes place at a much faster speed. But nevertheless, it's the same reaction. So here, magnesium combines with oxygen in the air to form magnesium oxide. Let's balance it. 1 oxygen here, 2 here, let's put a 2 here, and 2 magnesium here in the product, let's put a 2 here. So this is balanced reaction, but this is the chemical equation, not the type of reaction. I wrote it so that you can see this and figure out what is the type of reaction here. This is one reactant which combines with the other reactant and forms one single product. There is no other product formed. So obviously this is a combination reaction. Okay, it's a combination reaction. Alright, now let's talk about observations. So the first observation, and before actually we get to that, let's discuss what counts as an observation. An observation is the physical changes that you see when the reaction is taking place. Like if there's a change in state, if there's a change in color, if there's an evolution of a gas, or if there's energy liberated in any form or energy absorbed in any form. That means if there's a change in temperature. Okay, so all these things count as an observation. But if in observation you write a combination reaction takes place, that statement is true, but I'm sorry, it doesn't count as an observation. Okay, so observation are the visual changes that you see while the reaction is occurring. So, now let's see what are the changes that we saw when this reaction took place. This reaction take place and there's a change that you cannot miss. The observation is that magnesium burns with a white dazzling light. White dazzling light. This also gives us a clue that the reaction is an exothermic reaction, meaning the reaction is releasing some sort of energy, and that energy is being released in the form of light, because light is a form of energy. So that makes it an exothermic reaction. Now some of you may say that it could also very well be an endothermic reaction, because here we are burning it, we are introducing it into the flame, so it requires energy. It does require energy, but for the reaction to start. After the reaction starts, the reaction is exothermic, right? Just like combustion of any fuel. When a fuel is being combusted or is being burnt, that fuel requires an ignition temperature for which you need to ignite it, light it or burn it. But as soon as that ignition temperature is reached, after that the reaction only emits energy in the form of heat or light. So combustion of fuel is an exothermic reaction. Just like that, this is also an exothermic reaction. Moving on to the next observation. You don't have to write what it was, but the observation was that a white powder was formed. Right? A white powder was formed and was collected in a watch glass. Now, this reaction, there is a precaution as well. And the precaution is we are suggested to not look directly to the white dazzling light that is produced. Okay, that might harm our eyes. So that is one precaution. Next question, and it's an important one. What is the nature of the oxide that is formed? Okay, or if the product formed, that is the oxide formed, is dissolved in water and tested for pH, what would you observe? So, the product formed, we know now, is magnesium oxide. It's a metal oxide, so it's basic. That's first clue. Then, when basic oxides or metal oxides are dissolved in water, they form hydroxides. Okay, and this also we know is a base. So when we test the solution with pH paper, we would see a red pH paper turning blue. Okay, or a universal pH paper turning blue. Okay, so that's all the questions I could think of, I could find from this activity. Right, let's move on to the next activity. Next activity is activity 1.4. You might notice two activities missing, 1.2 and 1.3. 1.2 I will take up after a while. 1.3 we will take up in the next chapter. Okay, so now let's discuss this activity. Here, what happens is calcium oxide, or what is the other name for this? Quicklime. Quicklime is added to water and a reaction happens. Okay, now see what the reaction is. Type of reaction, for that let's write the chemical equation first. So this is our calcium oxide or quicklime. Okay, I better use a different color pen here. So quicklime, when dissolved in water, gives us this. This is called as slaked lime. Okay, now see, A plus B gives us C. So obviously this too is a combination reaction. Moving on, observations. Now here can be, here also we can have two observations. First is that this reaction is also very exothermic. Exothermic reaction, or you may say that the test tube or the beaker became very hot. Okay, that's one observation. Second observation, you can see in the picture also, there is bubbles forming. So these bubbles are not because of some gas being evolved. These bubbles are because the reaction is so exothermic, so much heat is released that the solution sort of starts boiling. Okay, so the next observation is, you simply can write bubbles are seen. You can also say hissing sound was heard. You can also say the solution started boiling. They all will count as the same observation. Okay. Now, uses of the product. The product here is slaked lime, and this has a use that it's used for whitewashing. Okay, it's a whitewash. Which brings us to the next question. When we use this for whitewashing, the walls appear shiny after 3 to 4 days. Why does that happen? Explain with the help of a reaction. So, obviously, whitewashed walls means that there is calcium hydroxide, because this is the whitewash, right? Over 3-4 days, what happens is this reacts with carbon dioxide in the air and forms a layer of calcium carbonate. Now this calcium carbonate is the one that gives it shining appearance. Okay, so these are all the kind of questions that can be asked from this activity. Moving on to the next one. Okay, in this activity, there is ferrous sulfate heptahydrate. Ferrous sulfate heptahydrate being heated in a test tube, and some gases are being released. Okay, so now let's see. Okay, so here let's first start with chemical equation. We started with ferrous sulfate heptahydrate. These are actually green colored crystals. Okay, when heated directly onto the flame, it will first lose its water of crystallization. This will be lost. And what you get here would be anhydrous, would be called as anhydrous ferrous sulfate. Okay, and 7 water molecules have been removed. Color of this would be white. Okay, moving on to if we continue heating, actually if the flame is quite high, you may not even observe this white color. It comes and goes very quickly, because as soon as ferrous sulfate is formed and anhydrous ferrous sulfate is formed, it quickly breaks down to ferric oxide and sulfur dioxide and sulfur trioxide. Okay, this is the reaction that takes place. Ferrous oxide, sulfur dioxide and sulfur trioxide. Now, color of this is brown. So you may see that the green color changed to light brown first and then brown very quickly. And then as you can see that gases are also being released. So that would also be seen. Okay, so these would count as an observation also. First observation would be green crystals of ferrous sulfate turned white and then turned brown. Okay, you have to write this in words. Second observation would be gases were released which had the smell of burning sulfur. Gases were released which had the smell of burning sulfur. So burning sulfur has a very pungent smell. So that would also count as an observation, right? So these two are the observation. You may also state that along the sides of the test tube, some water droplets were noticed. That would happen when the water of crystallization would be leaving. Because this part of the test tube is still cold, water that evaporated here got condensed on the sides, right? So that would again be an observation. Okay, now what kind of reaction is this? When we talk about this kind of reaction where we have one reactant which is being given some sort of energy which gives us two or more products, that kind of reaction can be shown as like this. A gives you B plus C. Okay, now this kind of reaction is called as decomposition reaction. Decomposition reaction means something is being decomposed or being broken. This is the exact opposite of combination reaction. In fact, the other name for combination reaction is composition. So this is decomposition, means the opposite of that. These kind of reactions are always endothermic. Because to break something, you have to give in some energy. Okay, here we are giving energy in form of heat. So this particular reaction is thermal decomposition. Therm means heat. Okay, so this is thermal decomposition that's taking place. You can write thermal decomposition or just decomposition. Then the gas those were released when they are collected in a test tube and the solution is tested with pH paper, red and blue, what would be your observation? So gas released is sulfur dioxide or sulfur trioxide. When combined with water, they will form this. This is sulfurous acid formed when sulfur dioxide is dissolved in water. If sulfur trioxide is dissolved in water, you would get sulfuric acid. They are both acids, and they would be acids, of course, because these kind of oxides, sulfur is a non-metal. It's a non-metal oxide. Non-metal oxide are acidic. Okay, so the pH color of pH paper would go from blue to red. Okay, and the red would remain red. Okay, so these would be your observation upon dissolving the gases in water and testing them with pH paper. Now, there are precautions here as well. Whenever you are heating something in a test tube, you have to always make sure that you don't point the test tube towards your face or anybody else's face. Okay, so the obvious precaution is don't point the mouth of test tube, TT stands for test tube, towards your face or anybody else's face. Okay, you can expand on that, right? So this was activity 1.5. I've asked all possible questions from this activity. Let's now move on to the next one. A similar kind of activity. Here also we are heating something in the test tube. Okay, just one thing, lead nitrate. And there are fumes here, brown colored fumes. Okay, so this reaction would obviously also be a decomposition reaction. Simply because something is being decomposed. A biggest clue is you're starting with just one reactant. There was just lead nitrate in the test tube, nothing else. So that's your biggest clue. Okay, second thing is you're heating it. So decomposition reactions are always endothermic. That is the second clue. Third thing is there are more than one product. One is gas and the other is whatever is left in the test tube. So at least two products are there, at least, right? So these are the clue that the reaction that is happening here, it's decomposition reaction. Now let's talk about the observations. First is obviously a brown colored gas is observed. Okay, then you can say that a white colored substance remained in the test tube. In the test tube. All right. So these are your two observations. You may not be asked for two. You may be asked for just one. Okay. So in that case, mention the brown colored fumes. Right. Now let's write the chemical equation for that. In the chemical equation, I suggest that just remember the products and then balance it. Okay, lead nitrate is being broken by heat into nitrogen gas, nitrogen dioxide gas, which is the brown colored gas that is liberated. Then oxygen is also released, and then whatever is left is PbO. Okay, lead oxide. So these three are the products. Now let's balance it. So 2 nitrogens here. We can first start with putting 2 here. Then oxygens. 6 oxygen here. 1 here. 4 here. 2 here. So 7 here already. Okay. Now what do? We make it even. Okay. For that we can put a 2 here. Now we have 4, 2 and 2. That means 8. Okay. So for that, we can simply put a 2 here. Anyway, because we have made lead 2. So there would come a 2 here. Now, obviously, nitrogen dioxide would become 4. Now let's check the oxygen again. 6 times 2, 12. 2 and then 8, that is 10. right? And then obviously 2 more. Okay, so these are the total number of oxygen balanced. Now let's talk about the next question. This question is also very similar to the question that we have done. Here also the gas released is collected in a test tube and the solution is tested with blue and red pH paper. Which pH paper would change color? Or other way of asking the question is, tell us the nature of the gas evolved. Now, gas evolved was nitrogen dioxide. When treated with water, it actually forms both nitrous acid and nitric acid. Okay. Now, balanced. This reaction takes place. You don't have to write the reaction because it's not in your book. And the question doesn't require you to write the reaction. This is just extra information. You can very well answer the question by the observation that nitrogen dioxide again is a non-metal oxide. Non-metal oxide, when dissolved in water, they would give acids. Okay, so it would turn the blue litmus paper to red. Okay, so that would be your thing. Now, precautions. It would have the same precautions as before. Whenever you are heating anything in the test tube, you have to make sure you're not pointing the test tube towards your face or anybody else's face. Okay, this activity done. Let's move on to the next one. Now, this is an important activity. Electrolysis of water. A lot of questions can be asked from this topic, this activity. So here what's happening is, and you may have done this in lower classes, it's a very common activity. So what we do is, we take water and then there are 2 electrodes and there are inverted test tubes on those electrodes, right? Electricity is passed through it. Okay, and then we observe some bubbles. Now, interesting thing is, we don't observe same amount of bubbles in the both test tubes. Okay, so let's see what's happening and why. First of all, type of reaction. Here also you have just one reactant and that is your water, nothing else. One reactant and energy is being given in the form of electricity. Okay, so that means it's an endothermic reaction. One reactant giving 2 products. 2 products are being produced on 2 different electrodes. So one reactant, that is water, giving 2 products upon passing electricity, it's a clear indication that it's a decomposition reaction. The reaction obviously is also endothermic. Okay, now observations. Observation is first, gases are released. Gases are released. That is your first observation. Okay, in the 2 test tubes. The second observation would be gas released in one test tube is more than the other. These two would be your 2 observations which you cannot miss. Okay, now what's happening here? Here water is being broken into hydrogen gas and oxygen gas. Okay, let's balance the equation. 2 here, we had to put 2 here because there were 2 oxygens. Now there are 4 hydrogens, so we'll have to put a 2 here. This is the balanced chemical equation. Now, product at cathode, product at anode. Okay, now this one is important And there's a very easy trick to remember. You know that water has ions H plus and OH minus. H plus is called as cation and OH minus is called as anion. So cations go to cathode, cations go to cathode, anions go to anode. Okay, this is how the names of these electrodes are derived. Okay, cations go to cathode, anions go to anode. At cathode, if what hydrogen only is going, so obviously it would produce hydrogen gas. At anode, this is oxidized to O2. Okay, so these are your two products at cathode and anode. You may also be asked the charge on cathode and anode. Since cations are going to cathode, the cathode must be negatively charged. Right? And if anions are going to anode, if a negatively charged ion is being attracted to an electrode, that electrode must be a positively charged electrode. So anode is positive. Okay, moving on to the next and very commonly asked question, very important question as well. Vc by Va means volume of gas released at cathode and volume of gas released at anode. So at cathode, your hydrogen is released. At anode, your oxygen is released. Now look back at the reaction. For every 2 molecules of water, 2 molecules of hydrogens are being formed, but only 1 molecule of oxygen is being formed. So that means the molecules of oxygen formed are half of the molecules of hydrogen formed, right? So volume of this gas, hydrogen gas, would be double as compared to the volume of oxygen gas. Okay, and hydrogen is produced at cathode. So your simple ratio would be 2:1. Okay, now that was the easy ratio. There is another ratio that may be asked. MC by Ma. MC means mass of the gas released at cathode and Ma means mass of the gas released at anode. Now, at cathode, 2 molecules of hydrogens were released. At anode, 1 molecule of oxygen was released. We know that atomic mass of hydrogen is 1 and 2 times 1 is 2, then 2 again, so 4. And the atomic mass of oxygen is 16, so O2 would be 32 and this would be 1/8. So MC by Ma ratio is 1/8. Okay, don't be confused if the order is reversed. If Ma by MC ratio is asked, then you'll have to write 8:1. Okay, so these are all the kind of questions that can be asked from this activity. Now let's move on to the next activity. Okay, so here is the next activity, activity number 1.8. Here what's happening is we have taken silver chloride in a watch glass and we can see that sunlight is falling onto it. Okay, now since it's only one thing that we have taken in the watch glass and energy is being given to only that one thing, that is a solid indication that it's an A gives you B plus C type of reaction. In other words, it's a decomposition reaction. Okay, observations. The observation is that there's only one observation, and that is that we took a white salt, white colored silver chloride, and it turned gray when sunlight fell on it. So what's happening here? Your silver chloride is being disintegrated or being decomposed or being broken into silver and chlorine. Now chlorine, we know that exists as Cl2. So to balance, you will put a 2 here. To balance, you will put a 2 here. Okay. So this is your chemical equation for this activity. Now here, a very common question is that why silver salts are stored in dark colored bottles. We can see that obviously this change took place only in presence of sunlight. Okay, so sunlight is basically breaking it. So when we have silver salts, we store them in dark colored bottles so that light cannot enter or reach the silver salts. So how would you answer that? Silver salts are photosensitive. Basically, it means that they are sensitive towards disintegration by sunlight. Photo comes from the word light, right? So silver salts are photosensitive. They disintegrate in presence of sunlight. To protect that, to block the sunlight from reaching silver salts, we store them in dark colored bottles. Okay. Next question. Use of this reaction. This reaction is used in black and white photography. Okay, so this is all that can be asked from this activity. Moving on. Okay, now here we have an iron nail dipped into copper sulfate solution. Again, a very common activity. Many of you must have done it in lower classes. So, copper sulfate solution we know is blue colored solution. Okay, we have dipped an iron nail into it. Okay, as the time passes, there are some visible changes in the test tube. So what are those changes? First, let's discuss observations. So over time, what happens is the blue color of copper sulfate fades and slowly changes into bluish green. Okay. Second change is that the iron nail gets a brown color deposit, or a brown solid is deposited on the iron nail. A brown deposit. Okay. Now, what's happening here? What's happening here is you have two reactants in this test tube. One is the iron nail. The other one is copper sulfate. As the time passes, the copper is replaced by iron from its solution. Now copper has to leave the salt solution and go, and iron will take its position. That is because iron is a more reactive metal. A more reactive metal always displaces a lesser reactive metal from its solutions, from its salt solution. Okay, so that is what happens here. Iron being more reactive displaces copper from its salt solution and forms ferrous sulfate and copper metal. Now, very important and very easy to write the states here. Since we have a metal, this would always be solid. Since this copper sulfate is dissolved in water, it would always be aqueous. Here also, the metal would be solid and the solution would be aqueous. Okay. So all these kind of reactions where displacement occurs, it's very easy to remember the states. Okay. Now let's talk about type of reaction. Now where we saw that one metal displaced the other metal from its salt solution. So obviously this reaction is displacement reaction. Okay, it's A plus BC gives you AC type B kind of reaction. Okay, one metal displaces the other metal from its salt solution. Okay, so this is your displacement reaction. Now let's talk about a question. This is also your NCERT question, very commonly asked, but it's based on, it can be asked from this activity also. In refining of silver, the recovery of silver from silver nitrate involved displacement by copper metal. Write down the reaction. Very simple. We have silver nitrate, right? Aqueous solution. We have copper solid. That much is given in the question, right? Now again, copper being more reactive than silver would displace it from its solution. Okay, and would form copper nitrate. Now the thing is, it forms copper 2 nitrate and silver is displaced. Okay, this is aqueous, this is solid, this would be aqueous and this would be solid. Balancing would be required here, balanced. Okay, so that's all can be asked from, that's all that can be asked from this topic, from this activity. Let's talk about the next one. Here, activity 1.10. Here what's happening is, we again have two reactants, one in this test tube, one in this test tube, right? We are simply mixing them, and these are actually aqueous solutions. Aqueous solution means these salts, sodium sulfate and barium chloride, they're actually white colored solid salts. When they are dissolved in water, they form aqueous solutions, right? So let's see what happens. Here, what happens is, when you have aqueous solutions of two ionic compounds, sometimes what happens is they exchange ions. Okay, that means this cation would get rid of its own anion and would combine with the anion of this salt. Similarly, sodium here would combine with this anion. Okay, so just exchange the ions, write the correct formula. Now these kind of reactions are generally accompanied with precipitation. So there is a precipitation taking place. Now here also in this chemical equations, it's very easy to write the states. Both reactants would be aqueous, always. The other two reactants, one would be a solid precipitate and the other one would be aqueous. Okay, the one that is solid precipitate because it's not soluble in water and the medium here is aqueous. So as soon as it was formed, this being insoluble in water, it would settle down, it would precipitate out. It's easy to remember that it would be barium sulfate which would be a solid here, because we all know that sodium chloride, the salt, the common salt that we use, is very soluble in water. So it's not possible that NaCl would precipitate out. Only barium sulfate can precipitate out. Now, here observations. First observation would be a white precipitate is formed. If only one observation is asked, you just leave it at that. If one more is asked, you can write the change in color. Okay, so when we began, sodium sulfate and barium chloride, they were both transparent solutions. Okay, but when they were mixed, the solution had white precipitate, so it kind of turned white. So there was a change in color from colorless to white. But if only one observation is asked, always give this one. Okay. Now here the exchange of ion is taking place. Both are displacing. There are two displacement taking place. Two ions are being displaced. So we call them double displacement. Okay. It's an AB gives you CD. AB plus CD gives you AD and CB kind of reaction. Okay, when you write this, please pay attention that the cation, that means the first ion written here, would combine with the second ion written here. Okay, cation would combine with the anion, and this is the cation here, so this would combine with this anion. Okay, so don't just write AC and BD. Be careful about this. Okay, all right. And also, if definition of double displacement is asked, always just write there's an exchange of ion that takes place here in the aqueous solution of two salt solutions, right? Okay, now I said that there are 11 activities and we would be discussing one here and one later. So the time has come. Now we'll be discussing activity 1.2. Now here also a double displacement is taking place. Lead, that means the cation, would combine with the anion of the other salt, and cation here would combine with the anion here. Okay, so this activity had this as a colorless solution, this one also a colorless solution, but when they combined, it formed lead iodide. Now lead has a 2+ charge, so obviously I2, because iodide has a -1 charge. Then you have potassium nitrate. Okay, now here one would be aqueous and the other one would be a solid, that means precipitate. Now it's the lead iodide which is the precipitate, and it's a yellow colored precipitate, a very bright yellow colored precipitate. So if this equation is asked, the observation is formation of precipitate and change of color from colorless to yellow. Okay, moving on to the next activity. We have copper powder being heated in a china dish. Copper, as we know that it's a brown colored metal, so copper powder would also be brown. We are heating it. Okay, we are heating it. It might imply that it's a it's a displacement reaction, but it's not. Here, what happens is that copper combines with the oxygen in air. So even though it appears to be just one reactant, there's actually other reactant present in air. Very much like when magnesium combined with oxygen. Okay, so copper here combines with oxygen in the air and forms copper oxide, right? Now, copper was brown color, but copper oxide is black color. Okay, so when copper is heated in a china dish, it changes to black color because of formation of copper oxide. Okay, this reaction does not take place at room temperature. You have copper utensils at home and you have oxygen in the atmosphere, yet it doesn't turn black, right? This reaction requires a very high temperature, which you get by heating it directly. Now, when copper oxide, that black colored thing, is passed, hydrogen is passed over that, what happens is, and these two are heating, what happens is a reverse reaction sort of takes place. That means copper oxide turns to copper again. Okay, so the black thing becomes brown again. So what's happening here? Here, in the first reaction, we can clearly see that copper is gaining oxygen. In the second reaction, we can clearly see that copper is losing oxygen. Okay, so that gaining oxygen and losing oxygen makes this kind of reaction as a reduction oxidation kind of reaction. Reduction oxidation or oxidation reduction, or you can also call it redox. Okay, a redox reaction. Now, observation. First observation, copper went from brown to black. That would be the observation of the first equation. Observation of the second equation is that copper oxide, which was black in color, it went from black to brown again. Okay, they can ask you these observation for the reactions, like what is the observation of reaction A, what is the observation of reaction B, right? Apart from these observations, you can be asked about the oxidizing agent and reducing agent. Okay, now excuse me. Whenever a redox reaction is taking place, something is being oxidized and something is being reduced. Okay, so identify the oxidizing agent and reducing agent in reaction A and B. So let's talk about reaction A. Whenever you have to identify oxidizing and reducing agent, always think about the definition. Oxidation is gain of oxygen. Oxidation, gain of oxygen, loss of hydrogen. Reduction, gain of hydrogen, loss of oxygen. Okay, these two definitions would always help you find out the correct oxidizing agent and reducing agent. Now, what else you need to remember is that so whenever they ask you about oxidizing agent and reducing agent, what you need to keep in mind is that oxidizing agent is the agent which is oxidizing others. So if it's oxidizing others, it's the one which gets reduced. And reducing agent is the agent that reduces others. So it's the one that gets oxidizes itself. Okay, at the reaction. Reaction A, copper is being oxidized. So copper is going to be the reducing agent because it's getting oxidized itself. Okay, and oxygen, if this is reducing agent, then this obviously would be oxidizing agent. And it's very easy to remember. Oxygen can be oxidizing agent. Hydrogen can be reducing agent because the definition says gain of oxygen is oxidation. So who better to oxidize than oxygen? Okay, oxygen can give oxygen atom. So it would be the oxidizing agent. Similarly, in reaction B, copper oxide is being reduced because it's losing oxygen. So if this is getting reduced, this would be oxidizing agent. In B, oxidizing agent would be copper oxide because it's getting reduced itself. And reducing agent would obviously be hydrogen because who better to give hydrogen than hydrogen itself, right? So this is how you identify reducing agent and oxidizing agent. Then the last question of the last activity is define oxidizing agent and reducing agent. Just like I said, an oxidizing agent is the one that gets reduced and therefore oxidizes others. A reducing agent is something that gets oxidized itself. And oxidation reduction always take place together. That is why they are termed as redox reaction. Okay, that means that if something is getting oxidized, it is reducing the other thing. And if something is getting reduced, it's oxidizing the other thing. Okay, there's a give and take that takes place between oxidation and reducing agents. So obviously they have to take place together. Okay, I hope this video helped, and we would be talking about the activities of other chapters as well. Those videos would be out soon. So there are many questions which are asked from this activities, and they are usually 4 marker or 5 markers. So it's important that you know what can be asked from these topics, or at least you should know in and out of every activity. So I hope this endeavor helped, and if you need help with anything else, do let me know. Best of luck for your upcoming board exams, and if you like the video, please subscribe, like and share. Thank you.